So let's wrap up section 3A with some percentage problems. But before we look at some problems, I want to give you some of the tricks that I use when I'm at a restaurant or in a department store having to calculate a tip or a discount. Let me give you some of the tricks that I use in the real world, because remember, this course is about math in the real world. I had a student tell me something that I'll never forget in working with percentages. He said, I'm going to give him credit for this because I didn't come up with it. He said, my mom told me if it's 40% off, then it's 60% on, honey. I thought that was so funny, but it's so true. If you're getting a discount off of an item, that means the store is eating 40%. You're only paying 60% of the original price. So if I have to figure out a discount, let's say like in this case, 20% off of a price, then I know I'm paying 80% of the original price, so I just multiply that price by 0.8. And actually, it's much easier just to multiply it by 8 and then move the decimal. Okay, so let's suppose we have an item that costs $50, and it's 20% off of the price. Well, I know that it's 80% on, so I'm going to take that 50, multiply it by 0.8, actually times 8, but it gives me 40. So 8 times 5 would be 40, so I end up paying $40 for that item. Now you could do it the old way. If it's 20% off, then I would need to take 50, multiply it by 20%, that would be $10, and then subtract the $10 from 50, and guess what? I get 40. So I just multiply those two nice whole numbers. 8 times 5 is 40, so I'm going to end up paying $40. Okay, what about if you have to add tax to an item? That's one of those more than problems, because tax is a certain percentage more than the price. So if I want to find out what the price is for something including tax, and let's assume that the tax is 5%, then I just multiply that original price by 1.05. 1 is the original price. 0.05 is the amount that I am increasing it by. So it's 5% more than, so I just multiply by 1.05. And then what about tips? We know the standard tip is 15%. So to calculate a 15% tip, it's much easier for me to just calculate a 10% tip and then add half of that back to the first value. I don't know if that made any sense. So let me show you what I'm talking about. Okay, I got a $50. Well, the meal costs $50, and I want to add a 15% tip. Well, I can very easily calculate 10% of this, because that's just moving the decimal place 1 to the left. So 10% of 50 is equal to $5. Now, all I need is an extra 5% to get a total of 15%. Well, it's just half of this $5. So half of $5 is 5%. So if I can find 10% and add half of that back to that number, then that gives me a 50% tip. So it's just a quick little way to determine a tip. So half of $5 is $2.50. So my tip on that meal would be $7.50. Actually, what I usually do is just double the front number. So if the meal was $50, then I would just double that front number of 5 and leave a tip for $10. And that's somewhere between 15 and a 20% tip. So I like to usually I leave a little more than a 15% tip. So do you have any tricks that you use when you're out and about working with discounts, or something's on sale, or figuring out a tip? Anything that you can think of, I would love to hear from you. Send me an email. Let me know, oh, here's a little trick that I do. Okay, let's look at some percentage problems. Okay, so your basic, here's a shirt, The pre-tax price of that shirt is $17, and local sales tax is 5%. What's your final cost including tax? You could do it two ways, but I want to do it the fast way. This is like taking $17 and adding an extra 5% back to that, so it's 5% more than $17. So I can use the trick that I talked about by multiplying by 1.05. So 17 times 1.05 will give me the price of that item, the $17, plus an extra 5% to compensate for tax. So it's $17.85. The old way would be, or I guess I should say the longer way, would be to multiply 17 times 0.05. That would give us 0.85, which is 85 cents. And I'd have to take that 17 and add that 85 cents back to it, and that would give me $17.85. But hey, if I can do it in one operation, I'm going to go ahead and do that. Okay, read through 11. Get an idea of how you might want to solve that one. So example 11 states this. The number of housing foreclosures in 2008 was 398 million. This number represents the foreclosures in 2007, but up 81% over those 2007 foreclosure numbers. How many foreclosures were there in 2007? So I have a statement that I wrote here, kind of a math statement, I guess, which is the foreclosures in 2008, we know that number, but I'm just writing foreclosure 2008, is equal to the foreclosures in 2007 that are increased by 81%. That's what this statement is saying. And the way we increase something, it says it's up by 81%, so that means it's increased by 81%. The way we increase something by 81% is it's that more than, so I would multiply by 1.81. So just kind of look at the way I've interpreted this problem to begin with. So the foreclosures of 2008 represents a number that is 81% higher than the foreclosures in 2007. And if I want to add 81% to a number, then I'm going to multiply it by 1.81. So I've actually created a small equation. The 2008 foreclosures, which was 3.98 million, is equal to 1.81 times the foreclosures in 2007, which is what I'm trying to find. I'm trying to find out how many foreclosures were there in 2007. Well, this really turns into a simple algebraic equation. Where is my pen? There it is. Let me just go this way. Okay, this is really algebraically 3.98 is equal to 1.81x. X I'm just going to call is the name of the foreclosures for 2007. And if I had this algebraic equation, to solve it for x, I would just need to divide both sides by 1.81. And that'll give me the value of x, which happens to be the number of foreclosures for 2007. So 3.98 divided by 1.81 gives me 2.19. 2.198, so we'll say 2.2. Use my little wiggly lines that mean approximately equal to 2.2. So what does that mean? That in 2007, the foreclosures were approximately 2.2 million. Now you can always check this number. Take this number, 2.2 million, and increase it by 81%. See if you get 3.98. And it does check out. So read through example 12. Your dinner bill is $42.50. You leave $50. The question is, what percent tip did you leave? There are many ways to figure this out. I'm going to show you a couple, but I want you to think about it, come up with a strategy, come up with an answer, pause the video, and when you're done, put the video back on. So I've set up two different strategies depending on how you looked at it. Strategy A, I used that relative change formula that we saw earlier because I had a new value, I had an old value, or a new value and a reference value. Then I can very easily figure out what percent is $50 over $42.50. So the new value is $50, that's what you left. The reference value is $42.50, what the meal cost, and we divide that by the reference value, $42.50, and then times 100 to get that percent. So the new value minus the reference value over the reference value. So I end up with 17.64% tip. So I knew it was a little more than 15%. Second strategy is find out how much of that tip, how much of that $50 was actually the tip. So I subtracted 50 and $42.50, and I came up with a $7.50 tip. Well, I wanted to figure out what percentage of $42.50 was $7.50. So I set up a simple little equation. You didn't have to, but this is one way I did it. $7.50 is equal to what percentage of $42.50? Of means to multiply, trying to find the percentage, so it's a simple equation. Divide both sides by $42.50, and you come up with 0.1764, which is 17.64%. There are other ways you could solve this problem. These are just two that I chose to show you. Okay, example 13 states, a politician promises, if elected, I will cut your taxes by 20% for each of the first 3 years of my term, for a total of 60%. We want to evaluate this promise. Does he actually cut your taxes by 60%? This is an example of an abuse of a percentage. We have to be aware of the reference value. So if I cut your taxes by 20% for each of the first 3 years, I will end up cutting your total taxes by 60%. True or false? Think about it and then figure out how much does your taxes actually get cut by. So we find out that he does not actually cut our taxes by 60%, and it has to do with this reference value. So I came up with a situation. I said, let's pretend that we owe $100 in taxes when he gets into office. If he cuts it by 20% that first year, that means my taxes are cut by $20. So my taxes next year would be $80. Well, what if I get another 20% tax cut? It's not off of the 100, it's off of the reference value, the $80 that's left over. And 20% of that is $16. So if I take that from 80, next year my taxes would be $64. A 20% cut of 64 would be $12.80. If I subtract it from 64, by his third year in office, I would be paying taxes of $51.20. That is not a 60% tax cut. The question is, how much does he actually cut your taxes by? I'm going back to that relative change formula. The new value minus the reference value divided by the reference value, multiplying it by 100 to tell me what percent cut I have. What's the difference? What's the change in these two? So the new value was $51.20. Those are my new taxes. The old value was $100. And if I divide that by 100 and then multiply by 100, because that's what the formula states to do, I end up with a negative 48.8%, and that's interpreted as a tax cut of 48.8%. Not 60%. So beware of that reference value. So for example 14, a stockbroker offers the following defense to angry investors. I admit that the value of your investments fell 60% during my first year on the job. This year, however, their value has increased by 75%, so you're now 15% ahead. Let's evaluate that statement. As we evaluate this statement, I like to start with a value and just see how that value changes based on the information given. So I'm assuming I have a stock that's worth $100 and that I had a loss of 60%. So if I lost 60% of that, then that means my stock is now worth $40. Well, if that amount, the $40 that it's worth now, has increased in value by 75%, so if I increase 40 by 75%, I'd multiply by 1.75, I'd end up with a stock value of $70. That's not even the value I started with. So again, this is another case of be careful of the reference value. Even though the percentages may seem that way, the values do not turn out to be that. So you're still at a loss. So read this next one. A store advertises that will take 150% off of the price of all merchandise. What should happen when you go to the counter to buy an item? Well, if something is 150% off, they should be paying you to take the item. Okay, we're just being wary with percentages, understanding them, understanding maybe some of the abuses. And finally, this last one. Because of company losses, you agree to accept a temporary 10% pay cut. Your employer promises to give you a 10% pay raise after 6 months. Will the pay raise restore your original salary? What pay raise should you receive to obtain your original salary? And again, this is based on that reference value. So a 10% pay cut and then a 10% pay raise will not equal out to what your original salary was. So I'm going to do the same thing here. Let's assume you have a $1,000 salary. And if you take a 10% pay cut, basically taking 10% away from $1,000, you would get, or I should say, you would be making, multiply that by 10%, that's $100, and if you subtract it, you would be at a salary of $900. Okay, so now let's take that $900, which is our reference value, and increase it by 10%. So if I'm going to increase it by 10%, I'm going to multiply by 1.10. See what that gives you. So what that does is it gives you $990. It does not put you back at your original salary. So now the question is, what pay raise should you receive to obtain your original salary? So instead of an increase of 10%, the question is, what would I need to multiply that 900 by 1 point what to end up with 1,000? And you know, sometimes you could play the number game. It's got to be a little bit bigger than 10% because an increase of 10% only got us to $990. So if you wanted to, you could just put in some numbers and see how it works. So since 0.10 was too small, let's just go with 0.11. Next value up. See what that comes up to be. Well, if I multiply 900 times 1.11, I see that that gives me $999. That's really close to 1,000. So I would just estimate I would need approximately an 11%, and I bet it's 0.111. That might even get me closer to 1,000. But let's just say approximately an 11% raise would put me back at my original salary. Okay, so that finishes up section 3A. Now you should be able to go and do the homework without any problems.